Have you ever been in a sudden blackout, sitting in the dark and wondered what really happens when you flip a light switch and the room instantly glows? It seems like magic, but behind the scenes, there's a powerful process at work. And at the heart of it all is something called a generator. A generator doesn't create electricity out of thin air. It simply converts energy from one form, like mechanical energy from a spinning turbine, into electrical energy. Instead, it converts one kind of energy into another, making it possible for us to power everything from tiny phone chargers to entire cities. At its core, a generator works by using the principle of electromagnetic induction, discovered by Michael Faraday in the early 1800s. He found that when a conductor, like a copper wire, moves through a magnetic field, it causes electrons in the wire to flow. This flow of electrons is what we call electricity. A generator is designed to keep this process going by constantly moving conductors through magnetic fields. So how does it actually work? Let's break it down. A generator has several key parts: the rotor, the stator, and a power source. The rotor is the part that spins, and attached to it are magnets or coils of wire that create a magnetic field. The stator is the stationary part, usually made up of coils of wire placed around the rotor. When the rotor spins, its magnetic field moves past the wires in the stator, pushing electrons through the wire and generating an electric current. But how does the rotor spin in the first place? That's where mechanical energy comes in. This energy can come from a variety of sources depending on the type of generator. In power plants, steam produced by burning fossil fuels, nuclear reactions, or boiling water with geothermal heat pushes turbines that spin the rotor. In wind turbines, the wind itself turns the blades which rotate the rotor. In hydroelectric plants, flowing water drives the turbines. Even a small portable generator might use gasoline or diesel to power an engine that spins the rotor. Once the rotor is spinning and generating electricity, that current needs to be controlled and directed. Generators produce alternating current, or AC, because the movement of the magnetic field causes the flow of electrons to constantly switch directions. To make this electricity usable, the generator often includes a voltage regulator, which keeps the voltage at a safe, consistent level, and a control panel to manage output. What's truly amazing is how all these pieces work together so smoothly, almost like a hidden magic show happening behind the scenes, turning mechanical motion into the light that chases away the dark. The mechanical energy keeps the rotor spinning. The magnetic field pushes electrons through the wires, and the electric current flows into power lines, lighting homes and charging devices. Without generators, modern life as we know it would come to a halt. No lights, no internet, no running appliances. Everything depends on these machines quietly doing their job. So, the next time you flip a switch, think back to that moment in the dark during a blackout. Imagine the hidden journey of electricity, from a spinning rotor inside a generator to the glowing bulb in your hand. It's not magic, but it's pretty close.
Got a question about how something really works? Drop it in the comments and we might cover your topic in our next video.